Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, that is arithmetic of finance, what we are going to discuss today is amortization. So let's begin. After completing the very lesson today, my dear student, will be able to explain the term amortization. And number two, also be able to calculate the size of payments to amortize a loan. These are the two things I hope, my dear student, you'll be able to do after completing the very lesson today. So as usual in your favorite segment of the lesson, that is maths is fun. Today, my dear student, I will give you another group of numbers. This is very special numbers, and this group are called necessitic numbers. I will explain what are necessitic numbers after completing my lesson today, so don't go away. To begin the lesson, my dear student, let me first explain the term amortization. Amortization is a method of debt repayment, that is, method of offsetting a debt, where regular payment is set aside and that regular payment is now also made at a regular interval of time. And that regular of time it now take a set period of time. Let me just explain again. If those that collect loan from the bank, especially the income earners, the salaries earners, the bank usually said you should be paying certain amount. That is the regular payment. That is the regular payment. And that payment will now be made, for example, every 3 months. That is the regular interval of time. And for a period of maybe 2 years or 3 years, that is the set period of time. So that method of paying back the loan, is what we call amortization. And the size of the payments that will now be made will now be given by the formula. That is, R is the size of the regular payment that will now be made to offset the debt completely. Is given by this very formula, R equals to A multiplied by the bracket open. Inside the bracket, you have a fraction. Numerator of that fraction is I over denominator of the fraction. You have 1 minus, then another bracket open. Inside that small bracket, you have 1 plus I, and the small bracket raised to the power of minus n. This is the very formula that we now used to find the size of the regular payment that will now be made, for example, every 3 months to offset the debt that we have collected from the bank completely. Where A is the debt, that is the amount of the initial money collected from the bank. I is the interest rate per period, and N is the number of equal periodic payments. That is the number of payments that will be made completely throughout the period. We are going to take examples how we can make use of this to find the size of the regular payment to offset a debt. So let's just move. Example number 1, it says find the equal monthly payment that will now amortize a loan of 240,000 naira for 10 years at 12% per annum. Solution to this very problem. So this is the total money, that is the total debt, 240,000. And we would like to pay that debt in 10 years, and the payment is now monthly payment. And the bank charges 12% interest rate, compound interest rate on the unpaid amount. So let's just move. So first write down the formula, finding the size of the regular payment, because we like to know how much shall we be paying each and every month for a period of 10 years to offset this loan of 240,000 naira. So the formula R equals to A multiplied by bracket. Inside the bracket, you have I over 1 minus another small bracket, 1 plus I, and that bracket raised to the power of minus n. This is the formula. So what do we now do? We now find what is A, what is I, and what is n. So starting with A is the amount, that is the initial debt. And the initial debt is this 240,000 naira. So A is now 240,000 naira. That is the amount loan from the bank. The next is find the N. How many payments shall we make this monthly payment? For a period of 10 years, how many times do we make that very payment? So it's now going to be, that is 10, the number of years, multiplied by 12, because it is a monthly payment, and in each year there will be 12 payments. So 10 multiplied by 12 give us 120. So this there will be a total of 120 payments. So next is to find the I. You can see this is now 12% per annum. But anytime we make a payment, that is at the end of each month, the amount will reduce. So the interest, computation of interest will now be performed. So in that, my I is now going to be 1 over 12 because the interest will now be computed at the end of each and every month. So you have 1 over 12 multiplied by the interest rate, which is 12% per annum. So this multiplication and the division, if done correctly, you now have 0.01 in the decimal. So we now substitute my A, my N, and I in this very formula to find R. So now move. So you now have 240,000. That is your A multiplied by open bracket inside the bracket your I 0.01 over 1 minus small bracket inside you have 1 plus 0.01 and that bracket raised to the power of minus 120. 120 is your N. Look at it here. So what I'm going to do is to perform this addition in this inner bracket. So 1 plus 0.01 gives you 1.01 and the 1.01 raised to the power of minus 120. So what I'm going to do next is to find what will now be 1.01 raised to the power of minus 120. If you now use your calculator to find this 1.01 raised to the power of minus 120, if you did correctly, you now have 0.3030. This is the value. So what I'm going to do next is to subtract 0.3030 from this one. That will give me answer 0.6970. So what I'm going to do next is to perform this division of 0.01 by 0.697. If that division is done correctly, you now have 0.01435. And what I'm going to do last is to multiply this 240,000 by 0.01435. And if that multiplication is done correctly, you now have 3,444 naira. So this person that collected this 240,000 naira to offset this debt for a period of 10 years, he is now going to pay each and every month 3,444 naira. This is what he will now be paying each and every month. So let's just take one more example. Example number 2, it says a lot of 100,000 naira is to be amortized, meaning to be offset completely with a quarterly payment. A quarterly payment means payments that will be done every 3 months, and we would like to do that over a period of 4 years. And the interest rate on that loan is now 80% per annum, and the interest is usually paid on the unpaid amount, that is on the unpaid balance. So the question asks here is to find the size of the regular payment. That is, what amount shall we be paying each and every 3 months for this period of 4 years to offset this loan of 100,000 naira completely. Solution to this very problem. So writing down the formula that gives the size of the regular payment R equals to A multiplied by the bracket inside the bracket is I over 1 minus 1 plus I raised to the power of minus N. So there we get our A, our I, and our N. So starting with A is always the debt, the amount collected initially, which is 100,000 in this case. So A is 100,000 naira. That is the debt. Next is N. How many times do we make this payment? The payments that we would like to find the size of the payment that we shall be doing. How many times do we make such a payment? It says the payment will now be made quarterly basis, that is every 3 months, and for a period of 4 years. So I will now find how many payments that will now be done. So in a year, there will be 4 payments. And for this period of 4 years, there will be 4 multiplied by 4. This gives us 16. So there will be a total number of 16 payments. And I, that is the interest rate per time period. So I says, look at it, is 80%. But as the payment will now be made every 3 months, anytime payment is now made, the debt reduces a little. So we have to compute the interest at that very time. So in that case, you now have 1 over 4. That is 1 over 4 of a year, the quarterly time that will now be made, the computation of the compound interest multiplied by the rate of interest 80% per annum. If this multiplication and division is done correctly, you now have 0.02 in the decimal. So we now substitute in this very formula. R will now be equals to A is now 100,000 multiplied by the bracket inside the bracket. Your I is 0.02 over 1 minus bracket open 1 plus 0.02, that is your I, and that bracket raised to the power minus 16. 16 is your N. So we continue. What I'm going to do next is to add 1 and 0.02. That gives me 1.02. So next I'm going to do is to find what is now 1.02 raised to the power of minus 16. If you do that with your calculator, 1.02 raised to the power of minus 16, that will give you answer 0.7284. So I'll continue. So what I'm going to do next is to subtract 0.7284 from this very one. If that is done correctly, you now have 0.2716. So next I'm going to divide 0.02 by 0.2716. If that is division is done correctly, you now have 0.07364. So what I'm going to do last is to multiply 0.07364 by this 100,000. That will give me the size of the regular payment, 7,364 naira. This would now be the size of the payment that will now be made each and every 3 months for a period of 4 years to offset the loan of 100,000 naira completely. With this, I have come to the end of this very lesson, my dear student. I hope you find it resourceful. And let me just move straight to the last segment, Maths is fun, and explain necessitic numbers. So necessitic numbers and numbers expressed as some of the powers of its digits. And when those digits are raised to the power, and that power will now be exactly equal to the amount of digit in the number. Let's take examples. 370 is necessitic number. 1,208 is another necessitic. Let me just express this 370. 370 will now be equals to the first digit 3 raised to the power of 3 plus the next digit 7 raised to the power of 3 plus the next digit 0 raised to the power of 3. This power 3, I got this power 3 by counting 1, 2, 3 digits. That will give you the power because it says the power equals to the amount of digits in the number. So evaluating this result will take you, if you add, it will give you this number back 370. So 3 raised to 3 will be 27. 7 raised to 3, 3,343, and 0 raised to the power of 3 will be 0. Addition of 27 and 343 will give you the number back 370. Let me take the next number, that is 1,208. I can see 1, 2, 3, 4 digits there. So each and every digit will now be raised to the power of 4. Let me do that. So I'm going to have 8 raised to the power of 4 plus 2 raised to the power of 4 plus 0 raised to the power of 4 plus 8 raised to the power of 4. And evaluating this result will now give me 4,096 as 8 raised to the power of 4. 2 raised to the power of 4 will be 16. 0 raised to 4 will be 0. 8 raised to 4 is the same with this 496. And adding this 4 results will give you back the number 8,208. So this is another necessitic number. Other examples of necessitic number, you have 153, 371, 407, 1,634, 9,474, and many more. Thank you for your attention. We see more of those things in mathematics in our subsequent lessons.